Next, we'll get into some common design mistakes. So, common design mistakes such as laminations with excessively tight dimensional tolerances. This creates a short stamping die life and will increase your cost. Shafts with precision features such as splines and flats meant to be case hardened through carburization, austenizing, or quenching. This heat treat method inadvertently causes distortion that may need to be reworked, and often case creates an unacceptable percentage of scrap. Fixturing to prevent distortion is seldomly successful. Selecting the appropriate steels will help avoid some of these issues. Inappropriate use of geometric dimensioning and tolerancing. An example of that is using a position of concentricity between the concentric features or between circular features and a central axis of reference. We recommend to use runout instead. What it does is it allows an easier and more robust inspection method. Assigning geometric tolerances that add little value or increase quality. An example of that is runout tolerance smaller than the dimensional tolerance of a circular feature. If control of form is critical, the dimensional tolerance should be reduced as well. Inappropriate use of casting or porosity specifications. We see this a lot. Examples are applying structural casting specifications to cast induction rotors. They're two separate industries. Expecting cast rotors to be porosity free. We see these on prints sometimes. It's just not obtainable. There's going to be some sort of porosity. While some rotors, copper rotors, may have very little porosity, there's still some. Expecting radiology or ultrasonic inspection to provide a quantitative description of rotor porosity. It may show it, but it doesn't give you a quantitative value. Rotor and stator cores with dimensional and geometric tolerances suitable for only machine parts without providing the material allowances needed to the machine part. Some tolerances are simply just not achievable at all when you're dealing with rotor or stator cores. An example is perpendicularity less than 5 thousandths, parallelism less than 20 thousandths, length tolerance less than 2 lamination thicknesses. Fabricated or brazed rotors with the following features. Complex rotor bar cross sections. We like to keep the rotor bar cross sections simple to geometric shapes. No allowance for the rotor bar radial retention in high-speed rotors. End rings designed as one solid piece or made up of excessively thick laminations in skewed rotors. Again, radiology or ultrasonic inspection for brazed integrity. Neither will work due to the severe signal scatter created by the multitude of reflective surfaces in a circular end ring.